This is the third video for section 9.4. This is finding limits of sequences. If we look at the definition here for converges, converges means when the limit is a finite number, meaning that it's going towards one number. Diverges says when the limit is an infinite or non-existent. So that it would be headed towards infinity or it's undefined. You could look at it in that way. When we talk about finding limits, it's very similar to the end behavior asymptotes. So when we were finding limits of end behavior asymptotes several chapters ago, you're going to apply those same concepts. All right, so if we look at the beginning here, we've got determine whether the sequence converges or diverges, meaning does it have a limit or does it not have a limit? And then if it does have a limit, give the limit. So if it converges, give the limit. So if you notice the first one here, you've got 1/2, 1/4, 1/8, 1/16. And then it says, and continues on until you get to 1 over 2 to the n power. Well, the higher that exponent gets, the closer this number is going to get to 0. So if you were to plug in, let's say we go, right now this is 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth would be 1 over 32. 2 to the 6th would be 1 over 64. The bigger that number gets in the denominator, the smaller that number is going to get, the closer it's going to get to 0. So this one, we're going to say converges. And then they ask you to say where it converges to or where it's heading to, and it converges to 0. Okay, well, let's look at the next one here on the right. It says we have a sequence that's 0, 5, 10, 15, ... 5n. Okay, so meaning the bigger the number that you plug in for n, what's going to happen? Well, if I plug in 100, it's going to be 500. If you plug in 1,000, it's going to be 5,000. The bigger that n gets, the higher the number is going to be. So it's going to be heading to infinity, meaning it doesn't have a limit, meaning that it diverges. All right, if we look at the next one down here where I've got 3n minus 1. Okay, let's just plug in a few numbers so you have something to look at. If I say 3 times 1 minus 1, 3 minus 1 is going to give you 2. 3 times 2 minus 1, that's going to give you 6 minus 1, which is 5. Let's say we plug in 10. 3 times 10 minus 1, that's going to give you 30 minus 1, which is 29. If you notice, I'm going to continue to get bigger and bigger. The number that you plug in for n is just going to continue to get larger as we head to infinity. So this one, again, is going to be that it diverges. It does not have a limit. Okay, over on the right, this is like a rational equation. And if you remember our rules from rational equations, we look at the degree of the numerator over the degree of the denominator. So here I've got 2n over n. Both of them have a power of 1. Okay, well, when your power in the numerator matches the power in the denominator, then you look at your coefficients. So this would be 2 over 1. Whatever numbers you plug in for n, it doesn't matter because it's going to head towards an asymptote or an end behavior asymptote, which is 2. So this one we're going to say converges to the number 2. Okay, go ahead and pause your video and do the try problem down at the bottom where it says 3n minus 1 over 2 minus 3n. When you're done, unpause the video so you can see if you have the correct answer. Okay, this concludes the video for finding limits of sequences.